Saturn, a world millions of kilometers away. Far from the sun, deep in the freezing cold of space, Saturn is considered the most beautiful planet in the solar system, the most unique and visually striking planet of them all, with its elegant shape and breathtaking rings. It's the one we always associate with outer space. Ask any kid to draw a planet, and chances are they'll draw Saturn. But a lot of us, myself included, have always wondered, is Saturn really as beautiful on the inside as it is on the outside? Or is it all just appearances? Today, we're diving deep into the gas giant to find out what's really inside this magnificent planet. On October 15, 1997, the Cassini spacecraft was launched from Florida, USA. It was the first mission dedicated entirely to studying Saturn, its rings, and its moons. Unlike Voyager, which only spent a few days flying past Saturn on its journey to deep space, Cassini's main objective was to stay within Saturn's system for years. After 7 years of traveling through the solar system, using gravity from other planets to pick up speed, Cassini finally entered Saturn's orbit on June 30, 2004. But Cassini wasn't alone. It carried with it another traveler, a European space probe called Huygens. Huygens separated from Cassini and began its descent toward Titan, one of Saturn's most fascinating moons. The probe wasn't originally designed to land on Titan's surface. Its primary mission was to explore the thick atmosphere, analyzing its chemical properties, temperature, wind, and pressure. But just in case it did land safely, the mission team designed Huygens to be light enough to float in the event that it landed in one of Titan's methane lakes. They also equipped it with cameras to capture everything during the descent. As soon as Huygens entered Titan's atmosphere, its cameras started capturing amazing images during the descent. At the same time, its instruments began analyzing the moon's atmosphere. Interestingly, scientists discovered chemical reactions happening in the upper layers of Titan's atmosphere, an atmosphere made up of nitrogen, methane, and hydrogen. These reactions were forming complex organic compounds, which slowly drifted downward, eventually forming the thick orange fog that gives Titan its mysterious look. Over time, these compounds reach the surface of the moon, and they're believed to be the early foundation for amino acids, which are essential for life. Titan is thought to resemble Earth from 3 billion years ago, back when life was just beginning. About 20 kilometers from the surface, Titan's landscape started to appear clearly. Mountains, plains, sand dunes, and complex drainage systems formed by methane rain. Titan is the most Earth-like place in the entire solar system. And Huygens? It became the first probe in history to land on a world this far out in the solar system. Somehow, it managed to land safely. And just before its batteries died, Huygens sent back the only image ever taken of Titan's surface, a quiet, alien world covered in sand and rock. And that was the end of Huygens' journey. On the other side, Cassini was busy making some incredible discoveries around Saturn. The spacecraft flew extremely close to the planet's beautiful ring system. And for the first time ever, it collected physical samples of the dust and particles floating around the rings. Analysis revealed that Saturn's rings are made of tiny bits of ice, dust, and rock. And while exploring the rings, Cassini discovered extremely small icy moons made of the exact same materials, floating not only around the rings but even inside them. This discovery gave scientists an important clue about how Saturn's rings might have formed. In the ancient past, Saturn was just a gas giant with no rings. Then, one of its icy moons drifted too close and crossed something called the Roche limit. That's the distance at which Saturn's gravity becomes stronger than the moon's own gravity, tearing it apart. The moon was shredded, reduced to pieces of ice, dust, and rock. And over time, those pieces slowly spread out, becoming Saturn's rings. There's another possible theory too. Two icy moons may have collided with each other, and the debris from that violent impact formed the beautiful rings we see today, over millions of years. The Saturn system is a strange place, full of secrets. In November 1980, Voyager 1 took an amazing photo of Saturn. And in that image, off in the distance, you can see one of Saturn's smaller moons, Enceladus. But there was something odd about it. The photo showed a strange feature coming from the moon. Voyager wasn't heading toward Enceladus, though. So it simply took the picture and moved on, continuing its journey out of the solar system. No answers, just questions. 25 years later, Cassini arrived, ready to solve the mystery of this strange moon. As it got closer to Enceladus, something incredible appeared. Huge plumes of vapor erupting from the moon's surface into space. But these plumes weren't just vanishing. They were actually feeding one of Saturn's outer rings, helping to keep it alive and renewed. So, what were these mysterious jets made of? And why were they being ejected from inside the moon? To answer that, Cassini had to perform a risky maneuver, flying extremely close to the surface of Enceladus. At just 50 kilometers above the surface, Cassini passed straight through the plumes, collecting and analyzing the particles. And that's when scientists got their biggest shock yet. The plumes were made of salty water ice, which meant beneath the frozen crust of Enceladus, there was a massive subsurface ocean of salty liquid water. And that wasn't all. When they analyzed the vapor even deeper, they found tiny silicate particles. These kinds of particles only form in oceans where there are hydrothermal vents, hot, mineral-rich openings at the bottom of the sea. On Earth, these vents are home to entire ecosystems of strange life, completely independent of sunlight. So the question now is, could Enceladus support life too? After 13 years of exploring Saturn and its moons, and a total of 20 years in space, Cassini was running out of fuel. And so began the final chapter of its mission. The grand finale. In April 2017, Cassini started performing a series of incredibly risky passes, diving between Saturn and its innermost rings. The goal? To gather as much valuable science as possible before the mission came to an end. Then, in September 2017, Cassini made its final orbit around Saturn, a dive straight into the planet itself. In its last moments, the spacecraft fought hard to keep its antenna pointed at Earth, sending back its final data. And then, Cassini plunged into Saturn at full speed. And in the skies of Saturn, the mission ended. Cassini became a part of the planet it studied for so long. Now imagine this. You've traveled to Saturn. You're wearing a futuristic spacesuit, one that protects you from even the harshest conditions, and you begin your descent, straight into the planet itself. What would you see? As soon as you enter Saturn, you find yourself surrounded by ammonia clouds. The pressure here is about 1 Earth atmosphere. The temperature? Around minus 130 degrees Celsius, minus 202 degrees Fahrenheit. At a depth of about 170 kilometers, you descend into the second layer of atmosphere. Thick, dark brown clouds made of ammonium hydrosulfide. The pressure rises to 4 atmospheres, and the temperature increases to minus 70 degrees Celsius, minus 94 degrees Fahrenheit. This is where you'd start to feel Saturn's extreme winds, blowing at over 1,700 kilometers per hour, 1,000 miles per hour. That makes Saturn home to the fastest winds in the entire solar system. What makes it scarier is, it's getting darker. The deeper you go, the less sunlight reaches you. After descending more than 300 kilometers, you enter total darkness. Now you're in the 3rd atmospheric layer. Thick clouds of dark water ice. The only light? Occasional bolts of lightning. And not just any lightning. Strikes 100,000 times more powerful than on Earth. Good thing you're in your advanced suit. You switch on your night lights and keep going. Now you've reached a pressure of over 10 Earth atmospheres. The temperature is around 0 degrees Celsius, 32 degrees Fahrenheit. As you fall deeper, both pressure and temperature increase at a wild, dangerous rate. And now, you're entering the 4th layer, a massive ocean of liquid metallic hydrogen. This strange metallic ocean is what gives Saturn its powerful magnetic field. Here, the pressure is over 2 million times Earth's atmospheric pressure, and the temperature hits 9,000 degrees Celsius, 16,000 degrees Fahrenheit. At this point, you technically wouldn't be able to fall any further, because the density of your body and the surrounding liquid would be equal. But luckily, you've got that incredible spacesuit. So you keep diving. Weeks pass as you descend deeper into this bizarre alien ocean. Eventually, after falling over 60,000 kilometers, you reach the core of Saturn. It's believed to be about twice the size of Earth, made entirely of molten rocks and metals under unimaginable pressure. 10 million times Earth's atmospheric pressure and temperatures over 35,000 degrees Celsius. And that is where your journey ends. You realize the most beautiful view of Saturn is from the outside.